Hi, it's Mr. Springer again, chemistry teacher. And in this video, I'd like to talk to you about writing formulas for simple binary ionic compounds. And again, you probably have working knowledge of the fact that metals tend to form positive ions by losing electrons, valence electrons. Nonmetals tend to form anions or negative ions by gaining valence electrons. Remember, the whole idea is to get an octet or a full set of 8 valence electrons. And it's very predictable what the charges will be for most of these in the A group or representative elements. It's the transition metals where things get a little more complicated, but not much more. So let's just dive right in here. I've got a few already written out. The first one will be sodium chloride, very simple, table salt. First thing you need to know, be aware of, if it ends with IDE, it's just a simple binary compound. There are a couple of exceptions, but for the most part, that's what we're dealing with. So for sodium, we just need to find the symbol for sodium, which is Na, and the symbol for chlorine, which is what the chloride ion is made of, which is Cl. I like to then go back to my periodic table. I find that sodium is in the column labeled +1, so the sodium ion has a +1 charge. Chlorine has a -1 when it is an ion. It is the chloride ion, has a charge of -1. And the key here is that the whole compound, the formula needs to represent the fact that there is no leftover charge. There's no positive or negative charge left over. The sodium has a +1 charge, the chlorine has a -1 charge. They cancel each other out. So the formula will just be NaCl, sodium chloride. Let's move on. Sodium oxide. Again, we have our sodium ion, which has a +1 charge. Oxide is the anion version of oxygen. We see that oxygen is in the -2 column, so oxide has a -2. What a lot of students want to do at this point is just smash those together, and we get Na with a +1, O with a -2. We'll subtract, we get NaO with a -1 charge left over, but that is no good. That is still an ion. We don't want an ion. We want it to be a neutral compound. So in order to make this work out, in order to make these balance out and add up to 0, I'm going to need 2 of the sodium ions to balance every one of the oxide ions. So we need a 2, and we put it as a subscript in a 2O. That tells you there's 2 sodium ions for every 1 oxide ion. Now, nowhere in nature is there a sodium oxide Na2O molecule. This is part of a bigger ionic crystalline lattice, but the ratio, the proportion of sodium to oxide in the lattice Na2O. So we write that as a formula unit, Na2O. Sodium chloride, NaCl, also a formula unit. Some teachers get upset if you call those molecules. We'll call them formula units for the sake of peace and harmony all the way around. Let's move on. Magnesium bromide. Magnesium has a +2 charge, so I'm going to put Mg with a +2. And bromide, which is bromine, has an ion, and the -1, Br -1. Mg +2, Br -1. Again, we're going to need 2 of the -1s to cancel the +2. So it'll be MgBr2, magnesium bromide. Again, don't just smash them up and say MgBr+. That's no good. That causes chemistry teachers to lose their hair. Magnesium sulfide. Again, we've got the magnesium ion. We got sulfur as an ion. Sulfur is -2. Be careful, this isn't sulfate or sulfite. It's sulfide. +2, -2, they're going to cancel each other out. We're left with MgS as our formula for a magnesium sulfide. Pretty easy so far. We've got a few more here. How about potassium nitride? Potassium, of course, is K, which makes all kinds of sense to you. K with a +1. Nitride will be the nitrogen ion, which has a -3 and -3. Again, we're going to need 3 of the K's to balance out the -3. So it'll be K3N. What some people like to do, and I kind of do it myself from time to time, is a kind of a shortcut version of this. If we'll take the number, not the charge, just the number for the potassium, and make it the subscript for the nitrogen, and then we'll take the number, not the charge, that is the, not the plus or minus, I'm sorry, that is the charge on the nitrogen, just the number, move it over here, make it the subscript on the potassium. You'll see that the nitrogen has a subscript of 1, which we don't ever write, and the 3 goes with the potassium. And so if you crisscross, it kind of makes it easier for some people to understand. Let's do that again here. Calcium ion has a +2 charge. Nitride, we just saw, had a -3. And so if I'll take the 2 and put it on the nitrogen, and the 3 and put it on the calcium, I'll end up with Ca3N2, which matches what we've done in the past. It's just 2s and 3s are hard to justify unless, whenever I see 2s and 3s, I always want to go to 6. So if I have 3 calciums, that's +6, and 2 nitrides would be -6. Sometimes the crisscross just makes a little more sense. Forget about the plus and the minus. Just forget about them. They go nowhere there. Aluminum oxide. We've got aluminum here in the +3 column, oxide in the -2, Al +3, O -2. If we crisscross, do the switcheroo, we get Al2O3. See, the 2 goes there, the 3 goes there, and it's so simple to do. Very simple to do at this point. Iron 2 oxide, iron 3 oxide. Well, we're helped out here a lot because the Roman numeral 2 tells us the charge on the iron is +2. O, or oxide, we can always remember now is -2, so it's just one of each, FeO. If you happen to crisscross and they're both the same number, you would get something like Fe2O2, which needs to be reduced to FeO. Typically, when I see that, the first few times I see it, I go, whoop, 1, 1, and I don't count it wrong. After a while, it gets a little annoying. So make sure you're reducing, always reducing, if you can, on ionic compounds. Iron 3 will be iron with a +3 charge. Oxide has a -2. When we do the crisscross, Fe2O3, iron 3 oxide. So again, it's going to require a little bit of, if you're not going to memorize the charges, you're going to have to look them up. You've got to be willing to put forth a little bit of effort, either to memorize or to look things up. Now, I know over time, you're going to get to where you will memorize some even if you don't try. In fact, you may already have oxide as -2. You may have already memorized that just from what we've talked about here today. So hopefully this will help, and I'll see you next time.